Hello guys, good evening. Am I audible?
Yes, sir.
I gave one homework problem. Hello? Did you solve that question? 3.6. Calculate the Gibbs free energy and the equilibrium constant of the cell reaction. What are the answers? Banu? Banu? Dhanush? We solved this question 3.6.
Sir, we already solved it.
What are the answers?
Ask for calculation.
Calculate Gibbs free energy. How much Gibbs free energy? And equilibrium constant. What is the formula to calculate Gibbs free energy? Minus
E naught cell.
minus NF C naught cell. Kc calculation, equilibrium constant. What is the relationship between Gibbs free energy and equilibrium constant?
Minus 2.303 RT log.
Log Kc.
Log Kc. So calculate the Gibbs free energy value and Kc value.
So Gibbs free energy is minus 45548.
Minus
45.
45,548.
how much? 45,000
548.
548 joules. Okay. Give this Kc value.
So log Kc is 772000.
No. It should come 9.62 into 10 power 7. This is Kc. I think somewhere they did mistake.
Sir, I said log Kc, sir.
You say log Kc. How much?
777000.
This much?
No, sir. 17 you should cancel.
No, it's a very big value. It won't come this much. It's wrong.
So I got 808.38.
80?
8.38.
No, that's also wrong. Wrong. I think while substituting R value, the delta G value, maybe you did mistake. This is in joules. Minus 4.548. 2.303 RT log Kc. Minus plus. 2.303 into R value 8.314 into T value 298 log Kc. So log Kc is equal to 45548 divided by 2.303 into 8.314 into 298. Now calculate this value. How much is value? Log Kc value. Tell me, how much?
So 7.982.
7.982. So this is a log Kc. So now Kc is equal to log inverse means 10 power 7.982. Kc is equal to we may write 10 power 982 into 10 power 7. So 10 power 0.982. Calculate, you will get this answer. 10 power 7 and 10 power 0.982.
6 into 10 power 7.
How much?
9.616.
Okay. Okay. Enough. That is the correct answer. Kc value. Okay, a simple question. Given the standard electrode potential, K plus K value is minus 2.93 volt. Silver Ag plus to Ag 0.80 volt. Mercury Hg2 plus 2 becoming Hg 0.79 volt. Magnesium Mg2 plus becoming Mg minus 2.37 volt. Lastly, chromium Cr3 plus 2 Cr minus 0.74 volt. Arrange these metals in their increasing order of reducing power. reducing power. Range. Which metal is best for reducing process?
Potassium, sir.
Very good. Potassium G minus 2.93, highest now its value, so it easily loses electron. This is acting as a best reducing agent. Okay, that is the highest one. So lowest one is highest is potassium. Okay.
Lowest Ag.
Silver plus 0.8, correct, Ag. Then
Mercury.
mercury into Hg. Next,
Chromium.
chromium. Further,
Magnesium.
magnesium. This is correct order. So potassium is the best reducing agent. Write that on the order. Next question. Write the nearest equation.
Sir, we can't see the
Can't see,
question,
sir.
sir.
Okay, 1 minute. Write the nearest equation. And EMF of the following cell. So it's at 298 Kelvin. At 298 Kelvin. First one. Magnesium solid become magnesium 2 plus 0.001 m. Cu2 plus becoming Cu. Concentration is 0.001 m. is solid. We have to apply Nernst equation for this cell, and we have to calculate EMF also. Tell me Nernst equation formula. Nernst equation. Kushi.
Sir, E cell equal to
E cell is equal
E naught cell
E naught cell
minus 2.303 RT by NF
3 by NF.
log 1 by
Oh, okay, wait. So actually, here I will write equation, then tell me what will come here. Your equation is magnesium plus Cu2 plus becoming magnesium 2 plus and Cu. What do we have to write? Log? C?
Mg2 plus by CO2.
Very good. Mg2 plus product concentration by reactant concentration. Here product, these both are products. Here also these both are products. But this is a pure metal, no? So we don't need to write. Only ionic or charged species only we have to write. Mg2 plus concentration by Cu2 plus concentration. Now apply E cell is equal to E naught cell value directly I will write E naught cell value. This is later I will give you the value. This is 2.71. 2.71. Minus C. Temperature is 298 Kelvin. So instead of 2.303 RT by F, we may write directly 0.059 by N. So N value is how much here?
2.
2, because only 2 electron transfer is taking place. So 2 log of magnesium concentration.
0.00.
Yes. 0.001. May I write this one? 1 into 10 power minus 2? No, 10 power minus 3. 10 power 1 into 10 power minus 3. So 10 power minus 3 divided by copper concentration 1 into 10 power minus 4. So 10 power minus 4. 2.71 minus 0.059 by 2 log of 10 power minus 3, 10 power. So only 10 is left. So log 10 is equal to 1 only. So 2.71 minus this value 0.0295. Calculate this value. This is only equal. Comes in some words.
So 2.6805.
2.6, how much?
2.6805.
6 heads. Enough. Completed? Second one. Fe, here it is solid, becomes Fe2 plus, concentration is 0.001 m, salt bridge, H plus, it is 1 m, and giving H2 hydrogen gas, 1 bar pressure. Electrode is platinum electrode, solid. Here, E naught of hydrogen is 0.0 volt. E naught of iron note on this information. So here we have iron electrode and hydrogen electrode. Which is anode, which is cathode? Dhanush, which is anode and which is cathode? Anirudh,
So Fe is anode and hydrogen is in cathode.
anode is what?
Fe, iron.
Very good, iron. Okay, cathode is
Hydrogen.
hydrogen. Okay, fine. So now we have to write chemical reaction. So here, hydrogen is gaining electron, iron is losing electron. So reaction is Fe plus hydrogen, it becoming Fe2 plus, and hydrogen gas is formed. So here we have to take H plus, take 2 H plus. Iron is Fe. Iron losing the 2 electron, so hydrogen gas is produced. Okay. Now next equation, E cell is equal E naught cell minus, I'm writing directly because we are taking a 298 Kelvin now. So directly 0.059 by N log concentration of iron by,
Hydrogen.
very careful, concentration of H plus, but square is there.
H square. H plus.
Yeah, H plus whole square. Now calculate E cell value, E naught cell value. From these values, you have to calculate E naught cell. I think I gave you formula E cathode minus E anode. Apply that formula and calculate E naught cell.
So then what's E cell, sir?
What?
What's E cell value here, sir?
That's what E naught cell value. We have to calculate from this. So E naught cell is equal E cathode minus E anode. So E naught of cathode, cathode is hydrogen electrode. So 0.0 volt minus of minus anode is 0.44. So E naught cell is equal to now 0.44 volt. That value substitute here. 0.44 minus 0.059 by n is here how many electron transferred?
2.
2 electrons. Log of concentration of iron. Am I right? 1 into 10 power minus 3. Iron concentration. So 10 power minus 3 divided by hydrogen concentration is 1 m. So 1 m square. E cell is equal to calculate now final value. Log 10 power 3 minus 3, it will become plus value 0.44 plus 3 into 0.059 by 2.
Is it 0.03?
Total value 10, 0.38.
38.
Total.
Yes, sir.
0.5. 2. Next unit is it? 8 volt.
So can you take approx?
Yeah, approximately. What you got answer?
Sir, 0.53.
53. Okay, no problem. Taking 0.53. But here simple calculations, no. So mostly don't take any round off value. Suppose here any long something different value comes, then you may take round off value. The directly 10 power minus 3 means minus 3 will become plus 3, and you can get the accurate value here. Okay. Next third one. This is a tin and hydrogen electrode. Sn solid become Sn2 plus 0.050 m. H plus concentration is 0.020 m. Some hydrogen gas. 1 bar pressure. Platinum electrode. So now here what is anode, what is cathode? Prisha?
The anode is Sn and cathode is.
Anode is?
Sir, anode is Sn and
Very good.
cathode is hydrogen.
Very good. So anode is Sn. So tin is losing electron We have to write equation Sn plus H plus. So tin loses electron, hydrogen gains those electrons, so it becomes Sn2 plus and hydrogen 2H plus gives hydrogen. Now that is the equation. E cell is equal to E naught cell minus 0.059 by N log of concentration of Sn2 plus by concentration of H plus square. How much E naught cell value?
0.14.
Very good. 0.14 directly. This minus this, it gives 0.14 minus 0.059 by N value 2 log of tin concentration. Yeah. So write this in scientific form. 5 into 10 power minus 2. 5 into 10 power minus 2 concentration by H plus concentration is
2 into 10 power minus 2.
2 into 10 power minus 2. So 10 power minus 2, 10 power minus 2 cancel. So 5 by 2 value.
Sir, that should be square, sir.
It's plus square.
Yes, very
sir.
good. Yes, correct. This is square. Yes. So E cell is equal to 0.14 minus 0.059 by 2 log of 5 into 10 power minus 2 by, this is 4 into 10 power minus 4. So what is going up will become 10 power plus 2. So 500 by 4. 0.14 minus 0.059 by 2 log of 500 by 4. 125. For simple calculations, you take here 5 into 10 power 2 by 4. So this one calculation 0.14 minus
Is the total
0.0295
answer 0.08?
total answer.
0.08, sir.
No, total answer is 0. Okay, approximately got correct one 0.078. Yes, correct. So here log 5 plus log 10 power 2 minus log 4. E cell is equal to 0.14 minus 0.0295 log 5 value 0.69 log 10 power 2 is plus 2 minus 0.6. 0.14 minus 0.295 here 2.09. Calculate this value. Actually 0.078 volt. Then fourth one. Platinum. Br minus 0.010 m become Br2 liquid. H plus 0.030 m H2 gas to 1 bar of the platinum electrode. So here E naught cell. First of all, see the reaction, chemical reaction. Br minus and H plus two Br minus, two H plus, use Br2 plus H2. One minute, no, the E naught cell of bromine is in some, it's not confirmed plus or minus. Yeah, 1.09, there is a plus value. Plus value, don't think. plus. Now substitute. Log of. So here, bromine not in aqueous phase and hydrogen also not in aqueous phase. That is a molecular form. So here we have to take only 1 bar hydrogen concentration only we are substituting here, just 1 bar. We are not substituting this value here. So here we have to substitute Br minus whole square and 2H plus concentration. So H plus whole square. E naught cell value
minus 0.1.08.
okay, minus 1.08 minus 0.059 by 2 log of 1 by Br minus concentration is 0.01 means 10 power minus 2 whole square and H plus concentration is 0.03. So 3 into 10 power minus 2 whole square. One 1.08 minus 0.0295 log of 1 by 10 power minus 4 and here 10 power minus 4, 10 power minus 7 is here, 10 power minus 8, sorry.
Be 9.
It should be 9, sir.
9 into 10 power minus 8.
9 into 10 power minus.
Oh yeah, it's 9
Minus
into,
8.
correct, 9 into. So 1 by 9, here 10 power plus 8. One by 9 value or 10 by 9 you take 1.11 into 10 power 7. So log 1.11 is 0.045. This value comes as plus 7. 7.045. How much?
Sir, minus 1.288.
Very good. Minus 1.288 volts. So suppose the reaction proceeds like this. So we won't get any voltage. The negative voltage means we are not getting any current. Suppose if we change the reaction, then only we can get current. Suppose bromine is undergoing reduction, hydrogen undergoes oxidation, then we can get some cell potential. So during this process, actually in this process, hydrogen is reduced, bromine is oxidized. Suppose if we change the reaction, this answer is correct. So this problem is the correct answer. Suppose the reaction Br2 plus H2 gives 2Br minus 2H2. And suppose the reaction happened like this in this direction. So bromine is reduced. At cathode, hydrogen is oxidized. At anode, then cell potential will come positive. Write this point out. So we have a lot of problems. Later I'll explain. Now the right concept, batteries. In here. So we already studied about galvanic cells. So here galvanic cell definition is cells which convert chemical energy into electrical energy. So in batteries, two or more galvanic cells, sometimes one also, one or more galvanic cells are connected in a series. That gives a battery. So here batteries are two types: primary batteries secondary batteries. So here, primary batteries, reaction have been takes place in one direction. So once the reactant is converted to product, so further there is no production of cell potential. For example, dry cell, torchlight cells, wall clock cells, batteries. Those only reaction takes place in one direction. Once the reactant is converted into product, further we won't get any voltage from the batteries. And those not possible to recharge also. Those are non-rechargeable batteries. Only one time is batteries. Next, secondary batteries. In this type of batteries, it is possible to carry out reverse reaction also by applying external voltage. Here, these batteries we can use again and again by supplying electric current through the battery in opposite direction. That means examples for secondary batteries: inverter batteries, mobile batteries. These all we can recharge now. So while discharging, forward reaction takes place. While discharging means while using the mobile phone, that battery's power is consumed. So reactant is converted to product. when you apply external voltage, external current, product is converting into reactant. So here reverse reaction takes place. This is the discharge. This is while charging. While charging, this reaction takes place. So those batteries are called secondary batteries. Secondary batteries examples: mobile battery, inverter batteries, nickel cadmium batteries, lithium, lithium batteries, and even nickel battery, cadmium battery. So first we see about the primary battery. Primary battery, best example is dry cell. So don't write, just now listen. In dry cell, the container is made up of zinc. Container, it is made up of zinc, it acts as an anode. And here, carbon rod. It is a cathode. It is coated with manganese dioxide and carbon powder. So finally, it is surrounded by manganese dioxide along with carbon powder. So in between, this is anode. Container is anode, zinc metal. This is cathode, carbon rod. And outside it is coated with magnesium oxide and carbon powder. Between this anode and cathode, we are placing some electrolyte, that is ammonium chloride and zinc chloride. Ammonium chloride and zinc chloride. So this is the description of dry cell. Now see what is the anode reaction and what is cathode reaction. You know, at anode, oxidation takes place; at cathode, reduction takes place. At anode, zinc becomes Zn+2 and releases 2 electrons. At cathode, this magnesium oxide involved, MnO2 plus 2 electrons, along with this OH minus also involved. Sorry, NH4 plus. NH4 plus, no. Gives MnO and OH. Plus MnO and OH, NH3. Is that? So overall reaction. Zn plus MnO2, electrons cancel, gives rise Zn2 plus MnO and OH releases ammonia. This is the overall reaction. Mostly this batteries concept is asking for 2 marks. You have to write what is anode, cell, what is anode and what is cathode. Here cathode is carbon rod coated with manganese dioxide and carbon powder, that is cathode, and electrolyte. Electrolyte, it is placed between anode and cathode, ammonium chloride and zinc chloride. And then you need to write what is anode reaction, what is cathode reaction, and overall reaction. And some additional points about this. See here, ammonia is obtained, right? NH3. This ammonia is combines with, it combines with zinc ions and forms a complex. Zn+2 and NH3. It gives a complex ZnNH4, NH3, 4, 2+. So it forms this complex. And this cell gives 1.5 voltage. So you must have to note this point. It gives 1.5 voltage. Suppose if we draw electric current quickly from this battery, at the ending of this battery provides very less amount of voltage. I think you have more experience about this type of cells. In the beginning, they give more voltage. Ending, its voltage providing voltage is very less. Any doubt here about this dry cell?
No, sir.
At beginning it gives more voltage. At ending it voltage become drops. That's what on the top light. If we use the new batteries, its focus is very much high, and at the ending, suppose battery power is gone, it gives very less voltage. So this is about dry cell. So we're going to note down 4 points. First, right, what is primary battery or battery? First, battery definition. A battery consists of 2 or more galvanic cells connected in a series. Connected in a series. So it is a 2 types of battery, primary battery. And reactant have been converted to product. No more electricity is produced. The cell reaction cannot be reversed. So example, dry cell. Mercury cell. Okay, put subheading dry cell. Dry cell consists of a zinc container acts as anode. The cathode consists of a carbon bracket graphite. Carbon rod, surrounded by powdered manganese dioxide and carbon black. The space between electrodes is filled with a moist paste of ammonium chloride and zinc chloride. Now, electrode reaction. At anode, Zn gives Zn2 plus 2 electrons. At cathode, MnO2 plus NH4 plus 2 electrons gives MnO and OH plus NH3. Overall reaction, Zn plus M1O2 plus NH4 plus gives rise Zn2 plus MnO and OH NH3. The cell has a potential of nearly 1.5 volt. Ammonia produced during reaction forms a complex with zinc. In bracket, complex is Zn NH34 2 plus. Last point. When current is drawn rapidly, from the cell. The voltage drops. Voltage drops. Okay, completed. Anirudh,
Completed, sir.
Kavya,
Completed, sir.
Tejashwini, Ritesh.
Done, sir.
Okay. Prisha,
They're just writing the last part.
okay, right.
They're done.
Okay. Okay, see the dry cell diagram. This is a dry cell diagram. As in examination, not mandatory, draw this diagram. Just to see how it looks. This is dry cell, and now I'm going to explain mercury cell. So where we are using this mercury cell? This is mercury cell. Do you have idea where we are using that mercury cell?
Watts.
Very good. Watch. Correct. So now see about mercury cell. Mercury cell also comes under primary batteries only. See, in mercury cell, amalgamated zinc mercury amalgam. Acting using an anode. zinc mercury amalgam is acting as anode, and mercury oxide with carbon black, it acts as cathode. Zinc mercury amalgam is anode, mercury oxide and carbon black is cathode. Electrolyte is potassium hydroxide and zinc oxide. Okay, in examination must have to write what is anode, what is cathode, and what is electrolyte after electrode reaction. Directly one, right. Right here, zinc mercury amalgam is the anode. A paste of mercury oxide and carbon. A paste of mercury oxide and
Sir,
carbon.
what is that after anode? So what is it after anode?
Amalgam is anode. This is anode. A paste of mercury oxide and carbon is the cathode. Is the cathode. The electrolyte is a paste of the electrolyte. The paste of potassium hydroxide and zinc oxide. And zinc oxide. Okay, now see electrode reactions. And anode. Anode is amalgamated zinc. OH, 2OH minus gives ZnO H2O plus 2 electrons. At cathode, mercury oxide plus H2O and 2 electrons. Use mercury hydroxide. Sorry, mercury only liquid mercury. Plus 2OH. Overall reaction, zinc amalgam plus HgO. OH minus 2OH minus cancelled. H2O 2 electron, H2O 2 electron cancelled. Only left is zinc oxide and mercury. So see this reaction, overall reaction. Here ions are not involved. In the overall reaction, there is no ions. That's what there is no change in the concentration of species. That is only the advantage for mercury cell over dry cell. Dry cell, you know, when we draw the electric current quickly, its cell voltage decreases, constantly it decreases. But mercury cell, throughout its lifetime, it gives a constant voltage. There is 1.35 voltage, constantly it can provide. But dry cell not being like this. At the ending, dry cell voltage is decreases, but mercury cell constantly can provide 1.35 volt. So note on that point also. The cell show a constancy. In potential throughout its life. The cell potential is 1.35 volt. Uses hearing aids, watches, clocks, torches. Okay. Right, next about secondary battery. In secondary battery, the cell reaction can be reversed by passing electricity through the battery. It means that can be used again and again. Can be used again and again through a large number of discharge and charging cycles. Example, lead storage battery. Nickel cadmium storage battery. They completed. About this secondary batteries, we have only two: lead storage battery and a nickel cadmium battery. Tomorrow class I will explain you. Thank you.
Thank you, sir.
Yes, sir.